Hey tech enthusiast, welcome back to Prime Coding. So this video is a continuous video of the part 1 which is mock test where I have given you two programming questions. So these programming questions are not the ordinary one. These programming questions were asked recently by Accenture in their on-campus placement drive on 16th of August and few questions are from 14th of August too. We'll continue this series of putting the coding problems which were recently asked by Accenture so that your Accenture preparation would be top notch. So without wasting time, let's solve this question. So given an array with n elements, fine, you are expected to find the sum of the values that are present in prime indexes. Okay, so this is the hint or this is a clue what we need to do in our code of the array. Note that the array index starts with 0. Great. The position index on the first array element is 0. The position of the next element is so okay. So it's a basic rule. So what I actually want to do it is we have an array 0, 1, 2, 3, 4, 5, 6, 7, 8. So let us move to the notepad and observe this question thoroughly. So yes guys, we are on our notepad. Now we can see we have given an array. Let me write their indexes. Okay, 2, 3, 4, then 5, then 6, then 7, then 8. Okay, so we have 9 elements in total. Now we need to find out the sum of those elements who are reside on prime indexes. Now we know what are the prime number, which is 2, 3, 5, 7. The numbers which are not divisible by any other number, leaving themselves and 1. Is it? So 2, 3, 5, 7 is the prime number here. So what happened is we need to add it up. Now 30 plus 40 plus at 5th we have 60 plus at 7th location we have 80. So 60 plus 40 is 100 and 100 plus 80 which is 180 plus 30. So putting 20 here, 210. So yes, 210 is the output that we need to generate right now. So pretty easy question, as you can expect these types of question for the very first question. Okay, if you solve this question, you are eligible for associate software engineer role interview. Fantastic. Now how you can solve it? Now if you have watched my recent uploaded coding video, the same type of question were there. There also we were finding prime numbers, and here we need to validate whether the index is prime or not. Okay, so that's the task 1 that we need to do. We need to check whether it is a prime number or not. Then second stuff, similar to finding the sum, but the tweak here is we need to find the sum only for those locations which are prime. So okay, for second terms we need to find a sum. Okay, so how I can do this question? Now finding prime number, we know n number of approaches are there. So recent approach, I use sieve and anthosis, which is a most optimal approach to find a prime number. But here I will let you know a more good solution, which is not that brute force, but it's also look good. Okay, so I know that here we have total number of 9 element, and what I will do, I will find the square root of it. So square root of it is 3. So I know it 3, any number in the range of 3, if my current number is divisible by 3, then which means it is not a prime number. Now what I am telling you is, okay, what we'll do here is we need to create a def check prime number. Okay, check prime function which will check whether the given number is prime or not. Okay, so check prime function will do that. Now how it will work as, well, simply we know the basic terminology of prime number. If let's say here is n has been passed, so if my n is less than or equals to 1, we know that it definitely can't become a prime number. Okay, so please return false. The function is returning a boolean digit. So now what I will do, I will iterate my loop from 2, because 2 is the smallest prime number. We know that, to where the square root of n. Okay, now what happened is total number of elements we have 9. The square root of 9 would be 3. Okay, so if any of the numbers which are in the range of 3, if any number is dividing a current n value, which means these numbers are not prime. So here what gonna happen actually is let it be if n, whatever n we have, is modded by I, whatever I, because we need to count on all the frequencies or all the numbers which are in the root of n. Okay, so I is equivalent to 0, which means it is fully divisible. Then you just need to return false. Okay, so I or the current I value can't become prime because of it is dividing and it is giving the remainder as 0. Fantastic. So this is the check prime function that we need to write. Now the second stuff is finding the sum. Okay, so finding sum is very easy. I will not waste time of explaining this. You just need to iterate over a for loop, create a for loop, iterate on I equivalent to 0 to n, and check for each. Check for each. Okay, check prime. Okay, check prime with I. If check prime is returning true, then you need to calculate the sum of those index values. Okay, so let's see the time complexity of this approach is, as we are iterating in the prime to root n. So first would be O of root n, and another we are traversing from till n, from 0 to n. So it would be O of n also. So the total time complexity would be O of n root n, and the space complexity would be O of 1, because we are not taking any auxiliary space. Fair enough. Now let's hop to the compiler and write this code. So as we discussed, the first step is we need to create a check for what prime number. So here I am currently writing in Python. Language is not an issue, but you can find the code snippet in the description for C++, Java codes. The GitHub link is provided in the description. Just head over to that and find the code. Okay, so right here I am using Python. So check prime first. I need to create the function. Then next would be passing on the addresses. Okay, passing on indexes. That's it. So two steps we need to do as we discuss in the approach. So let me create the check prime function. So check prime function is pretty similar like this, where n we have the n would be given to the check prime function. Or let me write the main part. Okay, so nums. Let's say we have nums here. The num value as 10, 20. Then we have 30. Then we have 40. Then we have 50. Then we have 60. Fair enough. Now what I will do, I need to iterate on each and every indexes. Okay, but I know from where 1 we know that till 1 no index value can become prime. So okay, starting from 2 till where, till the len of nums. Okay, till then the size of nums. Fantastic. Now I need a total which will store the answer of it. So answer equivalent to 0 for now. Now we need to check the location where the I is pointing currently is prime or not. So check prime I. If this function returns true, then we need to calculate the answer of it. So answer plus equivalent to nums of I. Bingo. Now you just need to print your answer as well. Now in your Accenture assessment, they might give you an inbuilt function where you just need to return the answer, but here I'm writing the code from scratch. Now let's complete our check prime function. Okay, so very first case is the base case, where if my n value is less than equivalent to 1, which means it never become a prime, or it can't return the as a prime number. Okay, now the second step is we need to iterate till the square root of n. So for I in range from 2 to square root of n. Okay, so basically we have n. So n 2 times exponential will give us a root of 0.5. Fantastic. Now we know that in Python we don't have the thing in rounding off as we can do in C++. If you initialize your n, I, anything int, then the multiplication, division, the decimal place would be removed. But here we need to typecast so that we'll get only the integer value, because the decimal places is not supported by for loops. So great. Now just need to check if my current n value mod I is giving us 0, which is fully divisible. If it is fully divisible, we know that that value can't become prime. And now just return true if both of the case being not passed, so that it means your n value currently that you are passing it is prime number. Fantastic. Return true. I guess we have written the whole code. So just let me run it. You will find 130 as a answer. Okay, because as you can see 0, 1, then 30 would be considered, then 40 would be considered, 2, 3, then 4, 5, then 60 would be considered. So 60 plus 40, 100, and 100 plus 30 would be 130, and bingo, you have solved your answer. So let's check out the second problem. So let's check out the 2nd of August 2024 Accenture OA question, which will help you to eligible for advanced associate software engineer role. Okay, so this question is bit tough if you have not cracked the logic. I have given you the hint in the mock test so that you can solve it. But if you're not able to, this video will help you out. So you are given a string S and your task is to find and return the count of permutation formed by fixing the position of the vowel present in the string. Okay, fixing the position of the vowel present in the string, which means, let's say if we have A, B, C with us, we need to fix the vowel place. Okay, vowel place is fixed there. So this place is fixed. Now you need to rearrange the rest over places which has consonants. What do you mean by consonants? Are there? Consonants are those alphabets which are not vowels. Great. So B and C are consonants here. So you can interchange this, and you need to let us know how many interchanges you can perform by leftover elements leaving vowels. Okay. So here we can see that A, B, C, if we fix A here, so you can either change C to B or B to C, is it? So there are only two ways to rearrange this particular string. So as you can see, the output is 2 as well. Now, what if there is no vowels consistent? Let's say it can be G, then it can be H, then it can be F. Now, so I will give you a better example of it. So let's say this. So marking these three lines will give you nostalgia of your class 10th, where you have studied permutations and combinations, where we need to rearrange these three letters in such a way that we can create multiple arrangements. So for filling the very first place, how many terminologies or how many terms we have? 3, which is G, H, F. So if we fill G here, then for this particular location, how many alphabets we left out? Which is 2. Okay, so which is 2. Now let's say you have filled F here. Now for this particular location, how many alphabet left? 1. So don't you think you have in total of 3 into 2 into 1, which is 6 arrangement of this problem? Is it? You can fill it 3, then 2, then 1, which itself means it is a 3 factorial, which demonstrate there are 3 factorial permutations of these arrangements. Fair enough. So we have cranked it out as we need to find the factorial of the given places. And if we have found the consonants, let's say like this, so we need to find how many vowels are currently present in the, or how many consonants which are currently present in the string, and we just need to find out the factorial of it. I think now question becomes very easy. So without wasting time, let's check out the pseudocode of this program. So yes, finding consonant, how we can do it is, let's say we'll create a string which consists of A, E, I, O, U and A, E, I, O, U as well, which tackles smaller case as well as uppercase too, because in question it is not specified that whether you will get a smaller case or uppercase. So let's keep this test case into our mind. Now what I will do, I will iterate on my string. Let's say for I equivalent to 0 to the len of string. Okay, so if, and I want a counter to which will count the consonants. Okay, so count equivalent to 0. So if, what if my S of I, which is, let's say if we are pointing on S, not S, let it be a input string, let it I. So I here is A, B, C. So if my S of I is not in my S, which means count the consonant. If the current character present in the S, which means it's a vowel, so we need to skip. Okay, but here what we are checking it, whether it is not in. If it is not in, then please increment your counter by 1 and follow this loop until you will not reach to the last location. Fair enough. Now just create a factorial function and push your count up, then you will get a factorial answer. What will be, you need to return or print it. Okay, simple enough code. So this for loop will take O of n time, and this factorial, if you use a iterative manner, it will also take O of n time, which means that the time complexity would be O of n. Okay, and the space complexity would be O of 1 because you're not taking any auxiliary space. Now let's check out the code. Now you might be thinking, Aditya, you have used not in Java or C++, we don't have not in, but you have an STL which is called vector and you can use as find. Okay, so dot find, if that particular character exists in the string, then you don't need to do that anything. If it is not exist, which means that particular character is consonant that you need to count it and just pass the number of consonant counts to the factorial function, which will return you the answer of it. Bingo. So let's start programming. Before going to the coding part, guys, if you are being confident that yes, you are able to solve coding problems and you are able to score well in mock test as well, which I am continuously uploading on my channel. So this is just for you to make your Accenture placement fully filled. What it is a mock session where n number of feedbacks is also written who got benefited by it, and the success story who convert this mock session and get the lakhs of rupees as an return. So yes, hundreds of rupees investment can give you a lakhs of rupees in return. You just need to book a session of Accenture where I will let you know about your weakness, where you need to work on your in detail feedback, how you need to represent yourself, whether your resume is up to the mark or not. Everything, the guidance to roadmap to doubt solving, everything is there in just in few bucks, which will give you as a return as in lakhs of rupees. So why you are waiting for? Just head on to this website and fill the form, then follow the instructions, and we'll meet you in the mock session. Now without wasting time, let's see the code of it. So as we discussed the approach, we need to do only two steps. First, to find the factorial of the number of consonants, and another to count the consonants, to count the consonants. Great. So let me write the function which is count the consonants first. So for now, I know that we definitely have an input. So let me write it as S. So S has an input like ABC. Okay, in the exam, it might you will get a pre-built functions, but here I'm taking an example. Okay, now what I will do it next is I will have a vowels that I will initialize, which is A E I O U, then A E I O U, which covers both the test case, whether the input given in the smaller case or upper case will deal with both the cases. Now, because the question it is not mentioned specifically. Now what I will do, I just need to check. Let me zoom a bit. How many consonants are there present in this string? So great. For I in range, then len of s I need to iterate on. Then if my s of I is not in my vowels, which means if that particular character is not in vowels, which means that the particular character is consonant. So now I just need to increment my counter, and if I'm incrementing it, I need to initialize it as well. So I've initialized it. Now what I need to do, I just need to create an answer and call this factorial function, which will get or which will give us an factorial of all the number of consonant present in the given string. So I will pass here as count value. Now on the last, I just need to print. In the exam, you may need to return the answer. Okay, so now writing the factorial stuff, which is def, then factorial of let's say n. Okay, now what I need to do is I just need to initialize a fact equivalent to 1. For I in range, just need to iterate on from 1 till n, so that n plus 1, so that n value would also be included here. And in the last, just fact, please reinitialize yourself by multiplying with the current element, and in the last just return the fact as an answer, because fact computes the factorial of n. Now here we are done with the code, and we know that there are two consonants, so the output will be 2 if we run this code. And see, the output is 2, and let me change the answer to F. So now there are 3 consonants, 1 vowel, so 1 place has been fixed, so the output should come as 6. So let me see, yes, 6 is coming. So bingo, you have solved this question in just O of n and O of 1 space, which is optimal also. So yes, if you are watching video till now, please subscribe it, share with your friends, so that you can contribute in their career building, because you have shared the great content with them. Prepare well. I have continuously posting the mock test. Please watch it. Let me know how many marks you have scored, and we'll meet you with a new video soon.